All right, so number two, we're given three sides, right? We're given A, B, and C. And remember, you can always draw a triangle if it helps to visualize what's happening. So we have 5, 6, 7. And so 5 is side A, so we'll call this angle A. 6 is B, so this will be angle B, and then this will be angle C. Okay, so if that helps, you can definitely do that. So remember that our formula is A squared equals B squared plus C squared minus 2 BC times cosine of A. All right. So this time we know all three sides. So we know A, B, and C, and we're actually trying to find an angle, right? We need to find some angle. So we can just start with angle A since it fits this formula really well. But remember, you could use this formula and do it with angle B or angle C as well. So, all right. But just make sure that here's the thing is that this has to be opposite of this. So if I want to find angle B, then this has to be B squared, and that means this will be A squared and C squared, right? So, and this will be A, B, and so forth, okay? So just remember that just remember that these two have to be opposites of one another, right? That angle and that side have to be opposites, okay? All right, so if I'm going to find angle A, then I'm going to plug in 5 for A squared. I'm going to plug in 6 for B squared, 7 for C squared, minus 2 times B times C times cosine of A, and we don't know A, so I'm just going to leave it as a variable. So now we're just going to, now we do have to do a little PEMDAS. We can't just plug this in our calculator because we have a variable here, so we want to isolate that variable. So what we're going to do is we're going to, once again, do a little PEMDAS. So I'm going to square all these. And I'll just square these and add them kind of right in the same step. And so 6 squared is 36. 7 squared is 49. 36 plus 49 is 85. Okay. And then on this side, 5 squared is 25. So I changed that. And then while I'm at it, I'm just going to multiply these together. Since we're subtracting in between, I can do that. So it'll be 2 times 6 is 12. 12 times 7 is 84. So it'll be negative 84. Okay. And then we'll bring down the cosine of A. All right. So now here's one thing that a lot of people try to do sometimes, try to subtract here. You cannot, right? This is attached to a cosine A. The 84 is attached to a cosine A. So those are not like terms. So you cannot combine these right here. You have to just subtract 85. And so we get negative 60 equals negative 84 cosine A. And then now we want to divide by negative 84. And so we get negative divided by negative is a positive 60 over 84. I could reduce that, but I'm not going to, just because my calculator is just going to do that work anyway. So now I want to get A by itself, so I'm going to take the cosine inverse of both sides. And so this is, once again, you're going to plug that in your calculator. So why reduce when your calculator can just work through that for you? And so I'm going to plug that in my calculator. And it comes out to 44.41. So that'll be 44.4. Oh, actually went around to the nearest degree. I'm sorry. So it'll just be 44 degrees. Okay, so that's angle A, 44 degrees. All right. So now I need to find another angle, A, B, or C. And so I could actually do the same thing again. If I want to, I could do the same thing again with and find angle B or angle C. Like I can put B or C here, then I'll have to put the opposite side here, the other two sides here, and then go through the same process again, right? but I think this is a little more work than law of sines. So I'm going to show you law of sines. You can kind of see them side by side. So if we do law of sines, then I have an opposite pair here, right? I have sine of 44. Now I'm going to store this as x because it was a decimal, and it was an infinite decimal, and so I'm just going to store it as x. Okay. All right. So store x comma t comma theta comma n, and then push enter, and now you have it stored as x. So I'm going to do sine of x, this angle I just found, over 5. Okay. Those are opposites. Equals, and then I can find either b or c. So let's find c since we found b last time. So I'll go sine of c over its opposite side. Okay. So remember, this is not a variable. This is just something we stored in our calculator. That's why I kind of made it a little different than a normal x, just to remember it's not a variable. So then I'm going to cross multiply here. So we end up with 7 sine of our stored value x equals 5 sine of c. So then I'm going to divide by 5. And we get sine of c equals 7 sine of stored value x over 5. And now we can take the sine inverse of both sides. And we can just plug that in our calculator. Those are going to cancel out. And so we'll get angle C equals, or is approximately. And we get 78.46. So that's just going to round to 78 degrees. All right. And now you can see which was more work, this or this. And it's definitely a preference thing. So you could think one or the other. To me, this looks a little shorter. But if this was more straightforward for you, or if it clicked a little better or whatever, you're definitely welcome to use that. Either way works. Okay. So now that I know this is 78, now we can easily find B, right? If we know these two, we can find the third angle. So we just do 180 minus 78 minus 44, and that equals 58. And so we can put a 58 in there now. All right. So we just solved this triangle. We found everything that's missing, right? Just like we did on the triangle before. But this one, with law of cosines, we had to find the angle instead of the side. So it's a little more work that way, right? With the side, we could just take the square root of both sides and plug it into our calculator. With the angle, yeah, we have a little more work to do, maybe a lot more. Okay. All right. So next, we're going to talk about when to use which trig, law of sines, or when to use law of cosines.